Hello everyone! Today we are going to be learning about elements. And when I say elements, a lot of you may say, I know the four elements: water, fire, earth, and air. No, I'm not talking about these, okay? I am talking about the scientific, the chemistry elements, okay? So, we're gonna learn what they are. Okay, now we're not going to be learning every single one of them. I'll just dive into some of the important ones. Okay, so as you can see here, I have actually consolidated all the elements into one table myself. Okay, well actually, it was not done by me, okay? It was done by a chemist named Dmitry Mendeleev. I don't know if I pronounced his name correctly, but yeah, okay, it's universally accepted as the table which contains all the elements. Okay, you can refer to all the elements here, and basically, everyone uses it. It's called a periodic table. And if you want to get to this website, it's very simple. Just search up periodic table on your search bar, and then you'll get to this page. Just press open it full screen. You can literally get it. And you can press on any element you want. You can literally read all about it. Okay? Now, firstly, we need to learn exactly what in the world are elements. Okay? But I keep saying elements, but what are elements? Okay, just in case you don't know, elements are basically, here is the definition of elements. Okay? Elements are pure substances that cannot be broken down into two or more simpler substances by chemical processes. So just remember this, okay? Basically, elements are like the tiniest unit. You can't break it down. Okay, now if we go over here to the periodic table, we can actually see it. Okay, now I'm gonna go through some of the basic elements that I think that you need to know about, but the rest I am not going to dive into it. You guys can actually search it up yourself, go to this website, and then go and study whatever you need to study. But I will just be going through the basic ones, and whenever I go through the elements, I'll be going through on two things. Number one, their symbol. Number two, their physical state at room temperature and pressure. RTP, I call it. So room temperature and pressure, it's physical state, like solid, liquid, or gas. Okay, so I'll just skim through some of the basic ones. Now, like you're probably watching this video because you're preparing for your next chemistry test. Like maybe your exam, you're tested atomic mass of certain elements. So I won't be going through I won't be deep diving into every single one of them. So what I want you guys to do is, if you have any queries, you guys can just literally go into this website and go and read up whatever you need to read up on, because I'll just be going through some basic elements and their physical state and RTP, nothing else. Okay, so yeah. Alright, so let's dive straight to it. Aluminum, Al, physical state at room temperature and pressure is a solid. Next one, calcium, which is Ca, it is also solid at room temperature and pressure. Iron, and you will probably think that iron is actually Ir, but it's actually not Ir, it's actually Fe. Okay, it's also a solid at room temperature and pressure. Magnesium, Mg, which is solid at room temperature and pressure, you can see melting point 650 degrees Celsius, which basically means that until it reaches something beyond 650 degrees Celsius, it will literally just be a solid. Okay, forever. It will just stay there, as a solid. Zinc, solid at room temperature and pressure as well, Zn. Copper, Cu. Tin, Sn. Silver, Ag. And lastly, Tb, lead. Now these are all solid at room temperature and pressure. Okay? And carbon, which is solid at room temperature and pressure. Iodine, which is also solid at room temperature and pressure. Phosphor, I don't know how to pronounce it, solid as well. Sulfur, also solid at room temperature and pressure. So these are all the solids at room temperature and pressure. Now for liquid, there are actually two that are important. Now of course there are more, but I'm just talking about like the ones that are important lah. This one, Hg, mercury, and Br, bromine. Now let's go through the gases, okay? Sorry. Argon, Ar, He, helium, Cl, which is chlorine, O, oxygen, and nitrogen, and that's it for gas. Okay, so these are basically the basic elements that I think you guys should know. Now, this is the technical stuff. Let's go through. That was like not the technical stuff. We're going through the technical stuff now. Okay, so You probably call these columns, and you probably call these rows. But actually wrong, they actually have a specific name. These are actually called groups, and these are actually called periods. Okay, so you guys must know groups and periods. Okay, now here's the very interesting thing. Okay, now you can see over here, these are groups, these are periods. Now, firstly, I'm gonna have to go through what an atom is. Okay, don't worry, I'm gonna go through. Now, an atom is basically there's a nucleus in the middle. There's a nucleus in the middle. Now, there are actually tiny particles inside, which are basically protons and neutrons. Now, I'll actually go through more about atoms in another video, which will be uploaded very late onwards. But don't worry, I will go through everything. Basically, we have a nucleus in the middle, which has protons, neutrons, and surrounding this nucleus are actually these things that are called electron shells. Okay, now in this case, how many electron shells are there? You can see that there's 1, 2, 3. If I draw one more outside, then you can see that there are actually 4 electron shells. Now, on every electron shell, there's actually some electrons on it. So, for example, look at this. It can vary. For example, this one has one. This one is like 4. So it's like, okay, let's say this one is 2, 4, 8. I'll just give you an example. Now, basically, on every electron shell, there will be a certain number of electrons on it. Okay, on every electron shell, there will be a certain number of electrons on it. And the outermost electrons, they are called valence electrons. So the outermost electrons on the outermost shell is the valence electrons. Now, protons are positively charged. They have a +1 positive charge. Neutrons are neutral, which basically means it's 0. And electrons is negatively charged, -1. Now, I will actually go through, now as I said just now, I'll actually go through more about atoms, like the atomic structures, in another video, which I will upload, not upload, what is my, okay, I will upload very long ahead. Like, you won't see it for like the next few months, okay, because it's more advanced topic and I need to go through the basic topics first, okay, but this is basically just a little sneak peek, okay. Now that you know how it works, let's actually go through everything. Okay, now this is called group 1, group 2, group 3, group 4, group 5. These are groups, remember? Group 1, group 2, group 3, group 4, group 5, whatever. Now, it's actually very simple. Group 1 means 1 valence electron. Group 2 means 2 valence electrons. It's very simple. Now, from group 3 all the way until group 12, these, I would say, indefinitive. Okay, it's very hard to actually, it's different for everyone and it's very not like specific. So group 3 to group 12, there isn't like a definitive like way of saying, oh, group 3 is this many valence electrons. No, they're all different. So basically, group 1, 1 valence electron, group 2, 2 valence electrons. From group 3 to group 12, these elements actually, they are called transition elements. Transition elements, and they are indefinitive. How many valence electrons, I also can't tell you. Also, I also don't know. 13, 14, 15. Now, there's 18 groups in total in the periodic table. 18 groups in total. Now, from group 13, it's not 13 valence electrons. You just look at the unit digit. In this case, 3 valence electrons. 4, 5, 6, all the way to 8. So basically, group 1, 1 valence electron. Group 2, 2 valence electrons. Group 13, 3 valence. 14, 4, 15, 5, 16, 6, 17, 7, 18, 8. From group 3 to group 12, it is indefinitive. They are transition elements. Valence electrons, basically, how many electrons on this outermost shell? Now that we know that, you'll probably ask me, how about how many shells are there anyway? So, okay, but firstly, let me talk about the groups. That means all these elements in group 1, They are all one valence electron, two valence electron. 13, group 13, 3, 4, 5. How many valence electrons? That's very easy. Now, these periods. Now, the period corresponds to how many electron shells. So, this you can see there's 3 electron shells. So, whichever element I'm drawing is definitely on period 3. Okay? So, this is an atom, but I'm still talking about elements that's still sort of related, and later I'll explain why. Okay, so it's everything very simple. If I'm on period 5, that means 5 valence electrons. Sorry, 5 electron shells. If I'm group 5, that's indefinitive. Group 15, there'll be 5 valence electrons. You guys can actually look and you can see. You guys can actually see this over here, this little structure. I'm on period 3, you can see there's 1, 2, 3. And if you actually carefully look at the outermost shell, it's actually 8 valence electrons, but I'm not going to count because it's too complicated. If you just look at something very simple like group 1, you can really see that on the outermost shell, there's literally only one single electron. So you can obviously, you can around here, you can literally see it. Okay. So, now, we know about how many valence electrons, so how many electron shells, but how about the total general electron? That is including the valence electrons. Actually, the number of electrons is the same as the number of protons as long as it's a neutral atom, as long as it's not an ion whatsoever, and I'll go through that in the another video, another video uploaded very late, as I said before. The number of electrons equals number of protons. Remember, electron is the -1, this one is the +1. The neutron is another thing. So, very simple. The atomic number is how many protons there are. What's the atomic number? This number over here. Iridium, 77. Lead, 82. Gallium, 31. Actinium, 89. For example, if I have actinium and I ask you, how many protons does actinium have? You can straight away tell me, bro, 89 protons, because basically corresponds to the atomic number, how many protons there are. And how many protons is the same as how many electrons. So that means also, in this case, 89 electrons. Now, I can't draw on this periodic table, but I'll literally use my little mouse to trace it, okay? I'm gonna like trace a little line. Follow the line. Okay, this is basically this little line I'm tracing up here. If you follow it, you'll probably see it's like a staircase, and you'll be like, why are you trying to prank us? Why are you trying to draw a staircase? This is not funny. I'm not trying to prank you. This is actually something very important. This is actually called the dividing line, which divides the metals and the non-metals. Now, to remember where the dividing line is, you basically just remember, you start the dividing line on the top left corner of boron. So boron is over here, the top left corner. And you basically just continue drawing a little staircase. Literally just a staircase. Okay, there's nothing else, just a staircase down from boron. Now, on the left side, which is basically everything here, like all the way here, right? They're all basically, if it's on the left side, they're all metals, except for hydrogen. Hydrogen is a non-metal. Okay, that's the only exception. But on the left side, they're all metals. The right side, they're non-metals. Simple as that. Okay, so that's basically that. And I will tell you what the difference between metals and non-metals. Now, metals, firstly, they are shiny. This one is dull. Or you can say lustrous if you want. Now, they have a high density. This one low density. So these are not the differences that you need to know. High strength as well. Metals are strong. I'm pretty sure you guys know that. Low strength. Okay, lock it in first. I'm gonna erase it because I want to keep scrolling downwards. Okay, now I'm gonna give you the next set of differences. Okay, metals are ductile and malleable. But non-metals are brittle and solid. Okay? There's another set of differences that you guys know. Just in case you guys don't know what COH is, COE is. COH basically stands for conductor of heat. COE stands for conductor of electricity. Now, please do not write trash COH, trash COE. Write poor. Okay. But actually, usually you don't need to write poor conductor of electricity. Usually, you actually just write this thing. Usually, you just write IOE, which basically means insulator of electricity. But you don't say insulator of heat. I mean, you can technically say that, but usually you just say poor conductor of heat. Basically, it's the ability to conduct heat or conduct electricity. Like, conduct heat is a better example. For example, if I have a cooking pot over here, right, I'm cooking something. Do you think this will be made of a conduct? It will be made of metal or not? Yes, this pot will be made of metal. Why? Because it's trying to conduct heat. That means it can like absorb the heat faster from the flame and heat the food up. You can cook faster. But how about this handle? Do you think it will be a metal or not? No, it will be non-metal, usually plastic. Because you don't want to get burnt. You're holding the handle. If it's going to conduct the heat so fast, it's going to reach here. Okay? So that is literally what it is. Okay? Electricity, same thing. Good conductor of electricity, insulator of electricity. Basically just means poor conductor of electricity. Please don't say trash conductor of heat, trash conductor of electricity. That's wrong. Okay, now next thing. Metals have high melting point, high boiling point, but these ones are low. And lastly, metals are sonorous, but non-metals are not sonorous. Basically, sonorous means that when they're hit, they produce a very deep, a very rich sound, like a full sound. That's very, like, you get what I'm trying to say. You just hit a metal and you know, okay, I hit a wood just now, and you can pretty much hear, if you can hear it, you can hear that it's not really that rich. If I hit the metal, it'll be like, I know how, I can't like make the sound, but you guys, I'm pretty sure you guys know what I'm trying to say. Alright, now, you can see that actually the ones in yellow, they're actually called metalloids. These ones in yellow, they are called metalloids. Now, metalloids have the properties of both metals and non-metals. They are called metalloids, right? Like boron, silicon, germanium, arsenic, antimony, tellurium. The ones that are highlighted, metalloid, they're basically metalloids, okay? Now, that's pretty much it for the periodic table. But now we're gonna actually dive into, hey, what are elements? Okay, but firstly, we need to understand the most tiniest unit. We need to tackle atoms. I'm not gonna go through exactly everything about atoms, but I need to explain to you what atoms are first. Now, atoms are the smallest particle of any element. Any element. Now, atoms are like the smallest unit of life, okay? But actually, there's a cell, but there's different things, okay? Atoms, okay? Atoms are the smallest atoms. Okay? Now, this is how it works. Some elements, now elements, there are actually a lot of different types. Elements can actually be monatomic, diatomic, or polyatomic. If it's monatomic, basically, it's only made of one atom. Diatomic, 2 atoms. Polyatomic, 3 plus atoms. Now, monatomic, when I say one atom, I really mean just one singular atom. Like one literal, one singular freaking atom. Now, diatomic, basically I'm made of two atoms together. Alright, and popular examples are hydrogen, nitrogen, oxygen, and these group 17 elements, they are all diatomic. Group 17 elements, they're all diatomic. Last but not least, we have polyatomic, basically means 3 or more atoms together. Okay? Now, diatomic elements and polyatomic elements, they are molecules. And now we'll understand what molecules are. So what exactly are molecules? Now, a molecule is a group of 2 or more atoms held together by chemical bonds. Now, molecules are two types. The first type of molecules are basically the ones that are made of the same atom. The other type is made of different atoms. Now, just so you guys know, just now when I gave the example of monatomic, diatomic, polyatomic, I don't care how many atoms it takes to make that element. It is always made of the same atom, the same type of atom. So for example, hydrogen is a diatomic element. It's only made of hydrogen atoms. Any element is just pure. It's not made of different stuff. It's just that made of the same atom. It may be one, it may be two atoms, it may be three atoms, but it will always be of the same type of atom. So every atom has a corresponding element. It belongs to a certain element. I don't care how many, but it will belong to a certain element. Now, molecules, there are two types, made of same atom and of different atoms. Now, made of same atoms, they are basically, if you think about it, the diatomic elements and the polyatomic elements. Right? Those diatomic elements, those polyatomic elements, they are basically just molecules as well, made of same atom. So just now when I went through, it's actually sort of linked. Elements, there are two types, monatomic and diatomic, polyatomic. Diatomic, polyatomic is made of two or more of the same atom. That's literally molecules in this category. Monatomic is just one, so one of course is not a molecule. It must be two or more. Now, made of different atoms, they are compounds, which we'll learn later. So they are a different category. Okay, they're basically called compounds. Now we'll learn what compounds. Compounds is gonna be interesting. Now, compounds. Compounds actually have a very, very simple definition. Basically, it's just containing two or more chemically combined elements in a fixed composition. Two or more chemically combined elements. Emphasis, two or more chemically combined elements. That means they're actually chemically combined. There's a chemical reaction. Now, these two elements, they must be different. That means you don't tell me I have a hydrogen element and I take another hydrogen element. Yay, I get my compound. No. It must be oxygen. And in that case, you get water, which is H2O. Okay. So, hydrogen plus oxygen must be different. Two or more chemically combined, which are different elements. Now, all molecules all compounds are actually molecules. Now let me explain why. Why are all compounds molecules? Now, what is the definition of molecule? Two or more atoms chemically combined. Now, in this case, we know that compounds is actually two or more elements chemically combined together. But as we said, atoms belong to elements. So when I say two or more elements chemically combined, actually what I mean is the root, which is basically the atoms. The atoms are actually combining, and that's also sort of element because they are sort of interconnected, sort of. So basically, if you think about it, all compounds, they are actually all literally molecules. All compounds, they are all molecules. Because it's all molecules, we know that it is two or more atoms chemically combined. And we know molecules are two types. The first type, just now I wrote, is the same atoms together. The other type is the different types of atoms together. Now, same atoms together, we already went through. Different number of atoms, that is compound. And that literally fits the definition. The molecules that are made of different types of atoms together, they are compounds. And compounds are also made of different elements. And remember, these atoms come from elements. Now, a big misunderstanding that a lot of people might have, you may have, and I also had once ago, one time, when I was learning this, was that, hey, you said that compounds are molecules. Yes, compounds are molecules. All compounds are actually they're all molecules. But we know the definition of compound is they are basically made of two or more elements. But the definition of molecule is two or more atoms. So are you trying to tell me that atoms are elements? No, not exactly. Atoms are not elements, but they are linked. They are sort of linked. Why are they linked? Because remember, elements, they come from atoms. Elements, they all come from atoms. For example, oxygen, this element oxygen comes from oxygen atoms. Hydrogen comes from hydrogen atoms. Nitrogen comes from nitrogen atoms. Now, all atoms belong to a certain element. It's like the parent. Okay? They are literally, basically, atoms are like the child of an element. Okay? Some parents have, some parents have one children, which is monatomic, two children diatomic, three children polyatomic, four children also polyatomic lah. And think above that, but I'm pretty sure won't have so many children lah. Now, here's the thing. Why am I drawing random stuff? Okay, now here's the thing. Remember, atoms, they all belong to a certain element. It's unique. That means atoms, I only belong to this element. I don't have like 1 million parents. I only have that one single parent. I mean, I know it's mother and father lah, but you get what I'm trying to say? So, some have the atoms. They all belong to a certain element. And only that element, no other element. So now you get what the contradiction is. You may say, oh, elements, are they the same atoms? They're not. But atoms all belong to a certain element. So that's why all compounds are molecules. Because molecules are defined by two or more atoms. And all atoms belong to elements. Belong to a certain element. And you may say, but wait a second, which is a big confusion a lot of people have. Wait, atoms all belong to elements, but what if it's not complete? Like, you know, some elements are diatomic, right? Example, O2. O2 is diatomic. It is made of oxygen atom number 1 and oxygen atom number 2. So how can we say, now what if I just cherry pick one oxygen atom? Here's the big misconception. A lot of people tell me this. Hey, I know that all atoms belong to a certain element, only that element. But for example, some elements that are diatomic or polyatomic, like for example, O2, oxygen, the element oxygen, it is actually made of two atoms. One oxygen atom and another oxygen atom, two oxygen atoms. So what if I just cherry pick only one? Then it won't be fully oxygen element. Oxygen atom now won't be oxygen atom. They won't be oxygen element. Because you actually need two in order for it to be fully an oxygen element. I understand that, but let me just give you an analogy. If I have a bowl of spaghetti, right, and I split it into half. Okay, spaghetti is a bad idea. Okay, let's say I have a piece of cake. I split it into half. This half is still cake. This half is still cake. Understand my point? If I have a cake, I split it into half. This is still a cake. This is still a cake. But it's just one half of a cake. This still belongs to the big ultimate cake, right? You get my point? So I know that O2 is made of two oxygen atoms, not one oxygen atom. But here's the thing. These oxygen atoms, one single oxygen atom, although it's not fully that big oxygen element, they still belong to an oxygen element. They still are like part of it, right? And they are still defined as an oxygen element. So you get my point now? That's why compounds and molecules, they have sort of like the same meaning, and that's why all compounds are molecules. So, all compounds are molecules. But, it doesn't work the other way. Not all molecules are compounds. Why? Because molecules, you know, there are two types. Type 1 is the diatomic, polyatomic, which are basically made of the same atoms. We've gone through this like the third time we're going through this, but I'm going to go through one more time. This is the element, the diatomic elements, polyatomic elements. This is the compounds. So this is incorrect. Not all molecules are compounds. Only some, which is under this category, are. Now you get what compounds are. Right? Compounds are actually very interesting. Okay. Now, just how you remember how I said chemically combined. Emphasis on the word chemically combined. Now, what if it's not chemically combined? That would be a mixture. Mixtures are basically atoms of the elements that are not chemically combined. They're basically compounds, but they're just like not chemically combined version. Now, just now when I said that just now for compounds, they actually have a fixed composition. For example, H2O. There's actually a fixed composition. It's like what makes it unique. Now, just to break it down for y'all, this H2, this is O. What does this mean? H2 means two hydrogen atoms. Atoms are not elements, which two hydrogen atoms are actually just one hydrogen atom now. But it doesn't matter, okay? This is one hydrogen atom. One oxygen atom. So, this is a fixed composition. It's just like that. But mixtures don't have a fixed composition. Alright? For example, if you have a mixture of oxygen and hydrogen, it can be in any composition. It can be HO3, which is in this case 3 oxygen atoms, 1 hydrogen atom. H4O2, 2 oxygen atoms, 4 hydrogen atoms. Okay, so it doesn't have to be like that. Okay, now, so that's basically what mixtures are. And just to help you guys visualize exactly the differences between compounds and mixtures, I'm gonna make a little list. Firstly, the composition. No, never mind. I'll just do it like how I did for the metals and non-metals thing just now. Compound mixture. Compound fixed composition. This one is not fixed. Now, compound, another thing is a compound has its own set of properties. Now, here's the thing. Hydrogen, I have 2 hydrogen atoms. I have 1 oxygen atom. Now, hydrogen has its own properties, oxygen has its own properties. But when you mix it up in one compound, that new thing that you have has its own properties already. It's like a magic, okay? It's magic, okay? It has its new properties. Okay, you get what I'm trying to say? I can't think of an analogy right on the spot right now, but you get what I'm trying to say? It has its own properties, own set of properties that it makes up on its own, but mixtures don't. Because mixtures are just like not chemically combined, they're just random stuff just thrown inside. So basically, it takes the properties of the substances that's made up of. So it does have its own set of properties. The properties are all basically just copycatted from the original substances. Okay, I'm not gonna write the full thing. You get my point. Now, compound. Now compound has a fixed melting point, fixed boiling point. Okay, mixtures don't, not fixed. Because mixtures are impure, and we'll learn this in the chapter of solutions and suspensions. But doesn't matter for now. Fixed melting point, fixed boiling point. And here's the thing: you cannot separate a compound. A compound cannot be separated by any physical means. Only like you use like chemical methods. Okay, but in mixtures, you can actually this cannot be separated by physical means. Mixture you can literally separate it very easily. We'll learn it next time. Don't worry. Separation techniques, we'll learn it like filtration, distillation, chromatography, crystallization. We'll all learn that. Can be easily separated by not chemical, physical means. And I'm pretty sure the last one, the most obvious one, compound, a chemical reaction is needed. A mixture, no chemical reaction is needed. To make the compound, you actually need to have a chemical reaction. Mixture, you just throw a bunch of stuff inside and boom, you get a mixture. That's all. Not exactly throw a bunch of stuff inside, but it doesn't have to really like mix together chemically. My point? So that's basically the difference between compound and mixture. Okay, thank you very much guys for watching. That's actually the end of this video. Hope you guys like this video. Hope you guys learned a lot of things. There's actually a lot of things that we went through today. You guys must revise it, okay? But I'm gonna give you guys a little mind map so that you guys can comprehend what I said better in this video. Okay, there we go. So elements can be monatomic, diatomic, polyatomic, but diatomic and diatomic, polyatomic, they are all molecules. Diatomic, polyatomic, they are all molecules. Just that they are the molecules, they are made of the same atom. Okay, as you can see, same atom. So basically, now remember, guys, this is a very big thing you remember. Elements are made of molecules. I'm going wrong. Elements are made of atoms, and these atoms are always the same type of atoms. That means you won't see like different types of atoms together. No. It's always same type of atom together. Okay? Same atom together. Okay, same atom. Alright. Now, elements are the same atom. They are monatomic, diatomic, polyatomic. Diatomic and polyatomic, they are molecules. Diatomic molecules, polyatomic molecules. They're basically molecules made of the same atom. Okay? Remember, elements, they are always made of the same atom, same type of atom. They're all unique. That means this atom belongs to this element. This atom belongs to this element. There's no such thing as this atom belongs to this element, but this other atom also belongs to this element, and whatever. No, it's always just this to this, this to this. Direct. Now, molecules can also be different atoms. There can also be different atoms in the molecule. So there are two types, same atom and different atom type. The different atoms basically means the molecules are basically two or more atoms chemically combined together. Okay, but these two atoms can be different. If they're same, then they go under this category. If they're different, they go under the compounds category, which are basically two elements chemically combined together. But what if they are not chemically combined together? Then you get mixtures, okay? So if it's chemically combined together, you get compounds. If it's not chemically combined together, you get mixtures, okay? So basically, that's basically it. Alright, and mixtures we will elaborate more on the next chapter. Not next chapter, but we'll learn it soon. Solution suspensions will learn it, and separation techniques will also learn it. But basically, this is the important part. Don't look up, okay? Don't look up. The thing on top is stuff you like, future stuff, okay? Basically, all these are very important. So thank you very much, guys, for watching. I hope you really like this video because please like and subscribe if you think this helped you, like if they help you, right? So yeah, okay, whatever. You get my point. Okay, I'm not gonna elaborate more. But share this to anyone you want to share it with, and if you have any questions, you can just drop them down. I will definitely answer them. Okay, I'm not being modest. I will definitely answer them. Okay, so thank you very much, guys, and peace.